All right, welcome to Notes 1-2 for Integrated Math 2. And today we'll be talking about negative and zero powers. So something that maybe we might have anticipated from yesterday, if we look back at some of these problems where we were dividing, right, maybe we would have anticipated, well, what's going to happen when we have more of a value in the denominator than we do in a numerator? Or if we're applying that subtraction property, right, from yesterday, what would have happened if when I subtracted, I had gotten a negative value, meaning that the number in the denominator was larger than the number in the numerator, the number of powers, I should say. And so that's what we'll be looking at today. So let's get started. All right, so today we're going to understand what is meant by negative and zero powers or exponents and simplify expressions involving exponents. All right, write each quotient in expanded form and simplify it. Then apply the quotient of powers property, which I'm going to refresh your memory, right? The division property is what they're talking about. The division property with exponents is that a to the m over a to the n is equal to a to the m minus n. Okay, the first one has been done for you. And so they had 2 to the 5th over 2 to the 8th. They've canceled out like pairs, and they end up with 1 over 2 to the 3rd. So 1 over 2 to the 3rd is the same as 2 to the m minus n, so 5 minus 8, which is negative 3. So what's going to happen is that this negative exponent does not make my value negative. It makes the negative exponent implies that the value is of the exponent and its base are in the denominator. So let's try one for ourselves. Okay, we have 5 to the 3rd over 5 to the 6th. And so like pairs will cancel. In the numerator, we need a placeholder of a 1, right? Everything's reduced to 1. And in the denominator, we have 5 to the 2nd. And so this means that if I have 5 to the 3rd minus 6, right? 5 to the 3rd, a to the m minus n, I have 5 to the negative, I'm sorry, that should have been a 6 here, and I put 1 too few, so let me put another 1. So this would be 5 to the 3rd power, I apologize. So 5 to the 3 minus 6 would give me 5 to the negative 3. All right, next we have a to the 3rd over a to the 8th. This time I'll make sure I count correctly. 1, 2, 3, 4, 5, 6, 7, 8. And so our like pairs, right, would reduce to 1. So we're left with 1 in the numerator. And in the denominator, we have a to the 1, 2, 3, 4, 5, a to the 5th. And so we have a to the 3 minus 8, which is a to the negative 5. So we notice that in both of these examples, 5 to the negative 3 means the 5 to the 3rds will be in the denominator. And in this example, a to the negative 5 means a to the 5th will be in the denominator. And then finally, we have x to the 4th over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these will reduce out our like pairs. And that gives me 1 over x to the 6th power, which is, if I have x and I take 4 minus 10, I'll have x to the negative 6. All right, so now they want us to see if we can derive a rule for a negative power. So this is the negative power property. So if I have something like 1 over x to the 6th, it's equivalent to x to the negative 6. If I have 1 over a to the 5th, it's the same as a to the negative 5. If I have 1 over 5 to the third, it's the same as 5 to the negative third. And if I have 1 over 2 to the third, it's the same as 2 to the negative 3. So I'm going to give you a second to think about what that exponent might look like. If you guessed that 1 over a to the n is a to the negative n, you are correct. So this property, we're going to be using it over and over and over again. I'm going to put it right here, the negative power property. The negative power property is 1 over a to the n is equal to a to the negative n power. All right. So now we can, oh, and by the way, the reason that this is really helpful is later on in math and calculus, it is much easier to rewrite something as a negative power than to try to take a derivative or integrate something like this. This is much easier to work with. Okay. So next, let's do the same thing for zero properties. So we're looking at what happens when we have, for example, the same exponent in the numerator and the denominator, and we're using, again, the division property, where we subtract the exponent of the denominator from the numerator. And so they've expanded it out for us for the first time, and we see that all the pairs cancel. Anything divided by itself is 1, and therefore 1 is the same as 2 to the 0 power. So let's check it out. We have 5 to the 6th over 5 to the 6th. And all of these will reduce to 1, 1, 1, 1, 1, 1. So this equals 1. So if I have 5 to the 6 minus 6, this is 5 to the 0 power. And similarly, I have a to the third, a times a over a times a times a. All of these will reduce out to a 1. And so we have that a to the 3 minus 3 is equal to a to the 0. And what we should notice here is that any power, like I discussed yesterday, any power raised to the 0 is going to be 1. And so this is called the zero power property, the zero power property of exponents. The zero power property is that any value a raised to the 0 power is 1, except for 0. 0 to the 0 power is not 0, is not 1. So that does not count for this case. And again, here's the zero property, the zero power prop. We're going to be using this one over and over. Any value raised to the 0 power is 1, as long as a is not 0. All right, we're going to use the properties of exponents to evaluate the following expressions. So 2 to the negative 3, right? So 2 to the negative 3, this is the negative power property. This will be the same as 1 over 2 to the third. And if they ask us to simplify it, this would be 1 over 2 times 2 times 2, which is 8. All right, the next one, we have to be very careful now because I see that they're giving us some negative values. So I have 10 to the second, and since I have division, I'm supposed to subtract the bottom exponent, which is negative 2. It is important that you remember you're using the subtraction rule and you're using a negative exponent. So this will become 10 to the 2. A negative times a negative is a positive. 10 to the 2 plus 2. I'm going to come over here to finish it off. 10 to the 4th power, which is 10 times 10 times 10 times 10, which is 10 to the, which is a 10 with 4 zeros, right? 10 to the 4th is a 10 with 4 zeros. 1, 2, 3, 4. So it's 10,000. I'm going to show this a second way. Another way that you could write this is if you know that a negative exponent means that this item is in the wrong location, right? A negative exponent means that this item really should belong up in the numerator. I can move this up to the numerator, just like here I moved this 2 over negative 2 to the negative 3 into the denominator, here I can move this into the numerator. So I could have 10 to the second and 10 to the, now it would become a positive 2, just like when I moved this one down, it became a positive 3, which would be 10 to the fourth. Whichever method you prefer, I prefer to just use the rule, but some students prefer to do this. And so this was B. All right, C, this value is going to become 1 over 3 to the second, right? We know that any value when it's negative in the exponent will move into the denominator. And 5 to the 0 power is just 1. And so this would be 1 times anything is itself. Well, this would be 1 over 9. And then finally for D, our answer for D would be anything to the 0 power is 1. All right, let's simplify each expression. So this would be 15x to the 0, a common error. So watch out. Students think that the entire quantity is being raised to the 0 power. But it is not. It is not. What is being raised to the 0 power is only the x. The power on the 15 is a 1. The power on the x is a 0. Therefore, x to the 0 becomes 1 by this property. So this is 15 times 1, which is 15. So similarly, this is negative 13 times 1, which is negative 13. And this is negative 2/5 times 1, which is negative 2/5. Okay, so based on your results in item 6, rewrite each polynomial so that each term is a power of the variable. So the variable in question here is x. So they want us to rewrite each term so that there's a power of the variable present. So the first term is already written that way. Negative 7x squared already has the power of the variable. Now, 3x, this is an x to the first power. We just don't normally write the 1. And then finally, 15, well, just like here, we could write it with 15 to the 0, x to the 0 power. That's what we're going to do. This is an x to the 0 power. We're going to do that for each of these. This is 16y to the fourth plus 24y squared minus 13y to the 0 power. Remember, y to the 0 power does not change this value of negative 13 because y to the 0 power is 1, and multiplying by a form of 1 does not change your value. The same thing here. So this one we have 5, and they're using z to the 0 power, and then plus 7, or sorry, z squared plus 7z to the third. And then finally, negative w to the fifth minus w third plus 3w to the first power minus 8w to the 0 power. So the goal here, they really want you to understand later in mathematics whether or not something has an even or an odd exponent. Like here, they all have an even exponent. Here, some of them are even, 5, 3, and 1, or sorry, some of them are odd, 5, 3, and 1, but 0 is even. Okay. It says, when evaluating and simplifying expressions, you can apply the properties of exponents, then write the answer without negative or 0 powers. So just like here, we don't write the 0 power, but they want you to see what that would look like for later in mathematics. But we generally will not write a 0 power. Also, we never leave negative exponents in our solutions. It's improper to leave negative exponents. All right, so on the first one, they want us to simplify, and I'm going to do it off to the side. Simplify this expression and write it without negative powers. Okay, so I have 5 x to the negative 2 y z to the 0 times 3 x to the 4th over y to the 4th. So something I think students find helpful is putting this, making both of these fractions. And now, as we've said before, anytime you see a z to the 0 power or anything to the 0 power, it's just multiplying by 1 so you can drop it. Next, I have 5, I'll rewrite it, x to the negative 2, y over 1 times 3x to the 4th over y to the 4th. I generally like to work with my numerators first and my denominators second, unless I happen to see, like if this were an x to the 4th and an x to the 4th, I would just reduce those out immediately. All right, so I'm multiplying my numerators. Remember, I'm multiplying the numerators. So I'm going to use the multiplication or product property. So remember, the product property was a to the m times a to the n is equal to a to the m plus n. So I'm going to add my exponents. So in the numerator, the 5 and the 3 will multiply. That's 5 times 3. The x to the negative 2 and the x to the 4th, I'll group those, and then I'll have a y over, in the denominator, I just have 1 and y to the 4th, so I'll just write my y to the 4th. Now, this is 15. I'm going to add my numerators, my exponents, which is negative 2 plus 4, and then y over y to the 4th. And then I'll simplify this. This is 15 x to the 2nd, y to the 4th. I'm sorry, not y to the 4th, just y over y to the 4th. And finally, I'll use my division property. And remember, my division property says that I will, division property says I'm going to subtract my exponents. So that's what I'll do. I'll subtract my exponents. I'll come down here. So I have 15 x to the 2nd, y to the 1st, and then minus 4, right? And so this gives me 15 x to the 2nd, y to the negative 3. Now, at this point, it is not fully simplified because we cannot leave a negative exponent. So what we'll do is we will rewrite this with this in the denominator, 5x to the 2nd over y to the 3rd. Now, clearly, you could see where your y's should have ended up. If you had expanded this out, I'm only going to look at the y portion, you would have had y and then y to the 4th in the denominator. And clearly, these will cancel and your 3 y's will be in the denominator. Okay, let's move on to the next page. It says try these A, B, and C. So I'm going to try each of these off to the side. So try these A. I have 2a to the 2nd, b to the negative 3rd, times 5ab. All right, I'll gather my like items. So 2 times 5, a squared times a, and b to the negative 3 times b to the 1. I'm going to leave my 1's on there so we don't forget that we're adding those exponents. So that's 10. We're multiplying, which means add our exponents. A to the 2 plus 1 times b to the negative 3 plus 1. And so this is going to give me 10, a to the 3rd, b to the negative 3 plus 1 is negative 2. And then I have to apply the negative exponent rule, which means that these are no longer going to be in the numerator, right? If I have b to the negative 2, this is the same as 1 over b to the 2nd. And so this will drop into the denominator. This is 10a to the 3rd over b squared. So again, this is 10a to the 3rd over b squared. All right, number 2, or b, we have 10x squared y to the negative 4 over 5x to the negative 3, y to the negative 1. I'll group my like items, so 10 over 5, and x to the second over x to the negative third, and y to the negative fourth over y to the negative 1. And I'm going to apply the quotient rule. The quotient rule is we're going to subtract these exponents. 10 over 5 is going to be 2. And then we will rewrite this as x to the 2 minus, now be careful because we have negatives after our minus sign. So negative 3 was your denominator. And y to the negative 4 minus, again, be careful, negative 1. Whenever I'm going to subtract a negative, I always write parentheses around it. So this becomes 2x to the, a negative times a negative becomes positive, so this is 2 plus 3. And y to the negative 4, this becomes a positive, so negative 4 plus 1. And so when I simplify my exponent, I have 2x to the 5th, y to the negative 3. And now we have to again apply that negative power rule. The negative power rule is that if I have y to the negative 3, this will be equal to 1 over y cubed. And so that y cubed will be in the denominator. So this should be 2x to the 5th over y to the 3rd. 2x to the 5th over y to the 3rd. And for C, they're kind of doing you a favor by giving you this one last. Anything to the 0 power is 0. Now, the difference between this one and the previous one, where I said be careful, because not everything was being raised to the 0 power right here, you notice there were no parentheses around this? If there had been parentheses around that, that would mean they're raising the entire base to the 0 power. In this case, that's exactly what's happening. They're raising all of these to the 0 power, and so this will be 1. All right, that was notes 1-2. I hope you're taking good notes and have a great day.